When we think of planets, we often imagine worlds like our own, rocky spheres orbiting distant stars, maybe with clouds, winds, or even oceans. But in the vastness of the universe, not all planets are gentle or Earth-like. Some are extreme. Some are monstrous. Some are so powerful that they challenge our understanding of what a planet can be. Today, we're diving deep into the most powerful planets ever discovered. Planets that crush, scorch, spin, and pull with forces beyond our imagination. Let's begin with size and gravity. One of the most powerful planets in terms of mass and size is HD 100,546b. This is a giant exoplanet located about 320 light-years away from Earth. What makes it powerful isn't just that it's big. It's potentially 6.9 times the radius of Jupiter, the largest planet in our solar system. But what's more astonishing is that it might still be forming inside a disk of gas and dust, creating shock waves as it grows. Its massive size likely gives it an incredibly strong gravitational field, capable of bending the paths of nearby objects, drawing in moons, or even clearing out entire areas of its star system. Now, imagine standing on a world like that. The gravity would be crushing, the atmosphere thick with gas and radiation, and the planet itself still radiating heat from its formation. This isn't a planet you visit, it's one you survive, if you're lucky. Speaking of gravity, let's talk about superjupiters. These are planets that are many times the mass of Jupiter, some as heavy as small stars. One example is Kepler 39b, a planet over 18 times Jupiter's mass. At this point, a planet is almost becoming a brown dwarf, a failed star. These worlds are so dense that their gravity would make it impossible for any kind of human life to exist. Even the strongest materials known to science would be crushed under their immense pressures. And their powerful gravitational pulls can even distort their host stars, literally tugging on them, stretching them slightly as they orbit. Next, let's talk about temperature and radiation. Kelt 9b is a record breaker. It orbits a star that's 2.5 times hotter than our Sun, and the planet itself reaches surface temperatures over 4,300 degrees Celsius, 7,800 degrees Fahrenheit. That's hotter than some stars. At that temperature, molecules can't survive. Even metals would vaporize in seconds. The atmosphere of Kelt 9b is being blasted by radiation, causing the planet to lose its atmosphere at a dramatic rate, almost like it's boiling in space. Kelt 9b isn't just hot, it's unstable. It's being stripped away layer by layer, transforming in real time. Imagine a world that's so close to its star, a year lasts less than 2 days. And the sun never sets. But power isn't just about size or heat. Let's talk about magnetic strength. Jupiter, right here in our own solar system, has the most powerful magnetic field of any planet we've found, at least 20,000 times stronger than Earth's. Its magnetic field traps radiation and particles, creating enormous belts of charged energy. If you could see Jupiter's magnetic field with your eyes, it would stretch millions of kilometers into space. Now, imagine a planet even bigger and more magnetically active than Jupiter. Some gas giants outside our solar system, such as Tau Boötis b, are believed to have even more intense magnetic fields, possibly powerful enough to generate auroras 1,000 times brighter than Earth's northern lights. These magnetic giants are not just scientifically fascinating, they're also dangerous. Their magnetic fields trap intense radiation that could destroy spacecraft electronics or fry any unprotected human. Another form of planetary power? Orbital energy. Consider planets like WASP-12b, which orbit so close to their stars that they are literally being torn apart by tidal forces. Their shape stretches into an ellipse rather than a sphere. Every orbit drags their material closer to the star, like cosmic taffy. WASP-12b is losing mass every second, forming a trail of gas spiraling into its host star. And eventually, this mighty planet will be consumed completely. The forces at play here, gravity, heat, magnetism, and orbital energy, make planets like these not just extreme, but doomed. They're slowly dying from their proximity to power. But the most powerful planets may be the ones we haven't yet discovered. There could be rogue planets, massive, cold giants drifting through space without a star. Some of them may be bigger than Jupiter, wandering in the dark, generating their own heat through gravitational compression. Others may be orbiting neutron stars or black holes, bathed in deadly radiation and tidal forces so intense that even light behaves strangely. And some might be made entirely of exotic matter, dense forms of carbon, ice, or even metal, formed under conditions we can barely replicate in labs.